A on the Scantron, minus 7 and 3. Choice B would be 7 and minus 3. Choice C would be 21 and 3. Yeah, I'm going to try to confuse you a little bit, right? You know what else I'm going to ask you? What quantity did you add or subtract? What was B over 2? I'm going to ask you what quantity. Was B over 2 quantity squared equal to 4? Was B over 2 quantity squared equal to 21 over 2 squared? Or was it 1 half? I'm going to try to confuse you. Okay? So you can get the right answer, but you can't, unless you complete the square method, you're not going to be able to answer the question. It's going to be a 2-part question or a 3-part question. Or I might give you something I know you can't factor. All I have to do is change this number here. Instead of being 21, I could make it 22. Okay? That's going to give you a different answer. Okay. Question? So this is the number I calculated that I need to add to this fragment in order to get a perfect square. The trouble is I can't just arbitrarily add 4 to the equation. I change it. If I just come in here and add 4, it's a totally different thing. But I could add 4 and subtract 4. Or I could add 3 and subtract 3. As long as I balance the equation, right? It's as though I added nothing. So whatever I need, I just subtract the same thing. Shuffle it over to the other side and keep what I need for the moment. Yeah, question? Either way, yes. Yeah. Depending on how you're, if you learned it the other way, stare at this for a while. Essentially, that's what we did. In fact, if you look in your textbook, you'll find examples of it doing it both ways. Basically, you're just balancing the equation. Whatever you add to one side, you do to the other side. Yeah. Okay, so you can expect a question like that. And the reason I give you this, I know you've seen this before. You just forgot it. Everybody forgets it. And then you're going to go into Calc 2 and you're going to need to do some manipulation. And I end up spending a class teaching people how to complete the square because nobody mentioned it to them for, the first year of college. So since I got you in pre-calculus, at least you've seen it and reviewed it at least once. So it'll be that much easier when you get to Calc 2 and other places where you're going to have to use that. Okay, so we did that problem. 17. Okay. Okay. Again, factoring, finding roots. Finding roots means find those things on the x-intercept. So I'm going to take this and I'm going to set it equal to 0. Do I need to do anything fancy with this? I could complete the square with this. That method will work. Because it looks a little nasty, what formula could I use? Could use the quadratic formula. Probably won't ask you that on an exam. I might. So you probably want to review it, but I could teach your little sister to do that in like 5 seconds, right? It's not hard, it's just a formula, right? Maybe factoring might be a little more challenging. Okay. What are the x things got to be? That's the best place to start. Yeah, got to have a 2x and got to have an x. What's the last number's got to be? 3 and 1 or 1 and 3. Somehow it's got to get to 3. 1 and 3. Something's got to be negative, something's got to be positive. And at this point, it gets kind of hard to guess. But you've pretty much eliminated a whole bunch of possibilities. And if you get it wrong, say again? Yeah, well, let's look at the inner product. A minus x and a positive, that's not going to work. I know it's wrong immediately. Try it this way. Okay, 2x times this gives me a negative 6x plus, bingo, got it. You see what you do? You just play with it a little bit. Okay? I think you all have seen that. I think you all know how to do that. It's just something you want to review so you can. Okay? It's a little bit harder than maybe the normal factoring. So what do I do now to find the x values, right? It's all about finding the x values. This one's easy. What does x equal? Yeah. This one, you scratch your head a little bit. Do it formally. Okay. It's always good on a test just to take your time, write it out, so you don't, I would have guessed 1/2, and then I'd have to, okay, is it a negative 1/2 or a positive 1/2? I'd think about it a little bit. In a testing situation, you're nervous, just write it out, okay? So make sure you get it right. X is 1/2, X is positive 3, minus 1/2, positive 3. Okay, all right. We don't want to do that. That's too easy. 1,643. Remember these? Yeah, that's a T. This is a T. Okay, because it's an and statement, this is less than this, I can set this up in this manner. 3t minus 2. And what goes on the other side? Negative 4, yeah. So it's a three-part inequality. And the objective is what? Get the t thing in the middle, right? Work from the inside outside. Okay, so I'm going to add 2 to both sides. This is going to be a positive 6. On this side, I'm going to have negative 2. Yeah, brain fade here. It's getting late. Minus 2/3 t less than or equal to minus positive 2. Positive 2. That's a t in the middle. Okay, so you know what that looks like on a numbering line. How would you write that in interval notation? With the small number, go to the larger number. Does that look? Square brackets, right? All right, square brackets. Now here's another one. See the difference between these two? Okay? One's an and statement, one's an or statement. The one on this side is an or statement. You can work these. Some of you have been taught to work these in a three-part like this. That's perfectly fine. The trouble is it's really hard to read them. So I usually don't teach that method. I just tell people, whenever you see something like this, remember there's 2 separate pieces. There's 2 arms to it. Because that sets you up for generally the correct solution. So this is going to be 3x plus 4 less than or equal to minus 2. And this is going to be 3x plus 4 greater than 2. So you keep one of these legs, you make the other one negative. and switch the sign there. And here again, when you go ahead and solve this,